All right, so the start of our new unit. We're going to be talking about the graph of a quadratic function. Remember, our general form for a quadratic equation is going to be ax squared plus bx plus c. All that information that we studied with factoring, this is where it's going to take effect. Right? So go ahead and copy this down as quadratic equation. We have ax squared plus bx plus c, where a is equal to 0. So the graph created is called a parabola, right? It's going to look like a U shape, or sometimes we'll see it upside down. But either way, it's going to look like a U shape. And there's some key pieces of information when we're looking at a parabola. We have our axis of symmetry, which is this line right here. I'm going to go and try and highlight it a little bit more. That's going to cut right down the middle. And basically everything is going to be mirrored across this line, right? I can draw a straight line across, like these 2 points are going to be at the same height, and these 2 points are going to be at the same height. And the last thing I want to really highlight is our vertex. That vertex is going to be the point at which where our parabola changes directions. It's going to be either the bottom point or our very much the top point. Okay. All right, so let's jump into our first couple examples. So we want to, example one, we're given a parabola. We want to identify a couple things. We're going to identify the axis of symmetry, the vertex, and the behavior. So go ahead and give it a shot. Well, the first thing is going to be, I always like to start with the easiest thing, right? So my first thing is going to be the vertex, right? And if we want to find that point, it looks like we're going by 2 every single time. This would be -2 here, so this would be a +2. So the point for the vertex is going to be 2, -4, right? We went to the right 2 and down 4. My axis of symmetry is going to go right through that vertex. So if I had to draw the axis of symmetry that was going to cut the whole entire graph in half, it'd be this line. And that line is going to be when x is equal to 2. It's going to be all the points. It's going to be my line where all the points are where x is equal to 2. And the last thing we need to do is we need to describe the behavior, right? So we want to describe when it's increasing. So our graph is increasing from this point on. So we can say that my graph is increasing when x is greater than 2, because remember, right here, that's when on my axis of symmetry, everything, when x is greater than 2, my graph is going to continue to increase forever. And if you look at when we're decreasing, right, I'm just following the graph here. When x is less than 2. All right, so that's example 1. Example 2, we want to graph. Go ahead and get a little more space down here. Yeah, we're going to graph the function g of x equals 2x squared and compare that to the graph f of x squared, right? So let's go ahead and pull up Desmos. Actually, no, before we do that, we're just going to look at the tables, right? So if we're going through this, right, if I want to say, we'll call this x, and we'll do g of x, and then f of x. So we'll say, we'll go from -2, -1, 0, 1, and 2. All right, so if I plug in, let's do the easy ones, right? So if I plug in -2 for f of x, so that's going to look like -2 squared. Well, -2 times -2 is going to be a +8. So my number here for my f of x is going to be 8. And again, -1 squared would be -1 times -1, which would be a +1. 0 squared is going to be 0. 1 squared is 1. And 2 squared is 4. So I actually made a mistake. messed this up. I meant to say 4, not 8. I don't know where I got this number from. So let's go ahead and fix that really quick. All right, so, oh, because I was thinking of the next one, that's why. All right, so if we're doing g of x, remember we're talking function notation, right? We have g of x, I want to plug in negative 2. So that means I'm going to do 2 times negative 2 squared. So this would be 2 times 4, which would be a positive 8. Let's actually write this in a different color. We'll do g of x in red. All right, and then if you want to do g of x of negative 1, right? So remember g of x is 2x squared. So whenever we have an x, I'm just going to replace it. So 1 squared is just going to be 2, so we have 2 times 2, which is 4. Okay, all right, so g of 0 would be 2 times 0 squared. 0 times 0 is just 0, so we have 2 times 0, which is 0. Then g of 1, we have 2 times 1. 2 times 1 squared is just going to be 1, so we have 2 times 1 is going to be 2. Ah, Mr. Siegel, you're messing up again. So this isn't, just looking at my notes really quick. Yeah, this shouldn't be 4, this should be a 2. We have a positive 2 here. You should notice that my numbers are going to be the same. Remember, it's our axis of symmetry. It's going to mirror the numbers exactly. So we can go ahead and guess that, hey, when x is 2, that my height is going to be 4. But let's go ahead and double check it. So g of 2 is going to be 2 times 2 squared. 2 squared is going to be 4. So we have 2 times 4, which is 8. So yes. Right? So here are our points. And we can go ahead and do that in Desmos as well. Don't worry, I'm not going to make you do this for both our last two examples. All right, so if you're going to do this, we're going to write, we'll type in g of x equals, and I want to write 2x squared. Right, that's one equation, and I want to compare that to the graph of my f of x, which would be f of x. Let's go and type in f of x equals x squared. Okay. So you should be noticing a couple things right off the bat. Let's make a table to really try and emphasize this. So not a folder, sorry, a table. And what I'm going to do is we're going to do negative 2, negative 1, and we can plug this in by hand if we want to, but I'm going to show you how to do this without plugging it in hand. So we have our function notation. This is why function notation is so important. I'm going to go over here and change my y1 to, say, f. But instead of saying x, we're going to say x1. So what's going to happen here is, let me go ahead and get rid of this a little more so I have a little more, I can see what I'm looking at. Whatever is in this x1 column is going to get plugged into my f of x function. So I need to write x, and then immediately after that we're just going to type 1. It's going to give us our subscript. And what's happening here is it's going to plug in the negative 2 into our function and pop out our result, and it'll graph the point for us. Okay, so let's go ahead and change the color so it's the same. If I can, by clicking and holding, and let's make this these points a little smaller. We'll go 0.5 just to make it a little smaller. Okay, perfect. All right, so the cool thing now is if I want, I can create another function in this same table by just going to the right one more, and now we're going to do g of x. So we have g, and we want to plug in the same x value. So we're going to say x1, and again, it plugged in each of those x values in. So if I wanted to, I can keep going and say like x of 3, I'd plug it in. 3 squared is 9, and 3 squared times 2 is 18, and you can see the points. Okay? All right. So what you should notice is as this number gets bigger, my function gets smaller, right? So the purple one was the 2 times x squared. Notice how it's narrower. That's because we're multiplying, it's growing faster. So our function is going to get closer and closer to that y-axis, or our axis of symmetry. If it's just x squared, we'll have something like this, on like the black line. Okay. All right, so what we'll notice now, let's go ahead and go to the next one. I'm going to go and delete all this. We'll leave our functions here. We'll call this, instead of saying h of x, I'm going to use f of x. I'm going to plug in, I'm going to graph h of x, which is negative 1/3 x squared, and compare that to the graph of f of x squared. So f of x equals negative 1/3 . Oh, whoops. Let's try this again. Sorry. I meant f of x, close parentheses, equals negative 1/3 x squared. And then we'll compare that to our g of x. Again, g of x, and you can see like it's already plotting the points for us because we use the same, the table. It's the same. So g of x is going to equal just x squared. All right, so first thing you should notice is when our number is negative, it forces our parabola to go from looking like a U to being upside down and pointing downwards. Right? And so the next thing is I'm going to go and delete the negative. So now this is even wider than we had before. Right? So before we had, let me type that in really quick. So we'll just type this as y equals 2x squared. The green one was the first one. The blue one was the one we just started, was our parent function, and the red one is the one we were just talking about, right? Notice how when we go between 0 and 1, it's going to be even wider than our parent function. So the smaller the number, until we get to 0, our parabola is going to open up more, and as the number gets bigger, our parabola is going to get smaller, narrower and narrower. All right, and that is the end of today. So there's going to be stuff in Delta Math. Go and take a look at that, and I will see you hopefully on Monday. Have a good day.